Okay, welcome back, guys. So last time when we had taken a pause, we were somewhere here where it was starting the RabbitMQ plugin, and after that, it has added some users here. It has created a virtual host using RabbitMQ. RabbitMQ is the task which does the postman job, which means from the Django it would accept a task, then pass it to is celery for the background job processing, and this the task and the message passing between celery and Django is handled by RabbitMQ. Uh, all those are explained in my WordPress blog. You can go and visit there. Uh, what we want to see here is that it has progressed and started the celery task, but with an error. We'll see what is the error. Apparently, it has ignored it and it has gone to the next step of configuring Apache web server. This is the step where we are configuring Apache plugin for web server gateway interface, which enables Apache to serve Python pages. And if you do, if you look at the playbook, there are a couple of more steps to go, and then we are done with the web server, the application server configuration. Okay, this is what it will do. It will start and stop Apache once again. And meanwhile, I would like to explain little bit more about the Ansible programming structure while this play is going on. Yeah. So after this, it would if we go to our main playbook, this is the main playbook. Once web server configuration is over, the task will move to configuring reverse proxy. This is the role. Okay. So we had one option of writing everything, the entire program inside this page. Okay, we could do that. The other option was to break them into roles. One role is for database configuration, one role here for the Django server configuration, one role here for reverse proxy server configuration. And by the way, when it reaches to this stage, the play will progress very fast because these are running on that broken server which was given as a complete node to OpenStack Nova. However, this is a standalone node, the RP server. I will just log in here. This is just to give you the architecture once again. Okay, so the reverse proxy is this side. It's left side of this external network. We have a bare metal server here, which then connects to internet. Okay, so rather than creating one more VM, we are utilizing existing setup. So you can consider here a imaginary line which is internet. In between we have the reverse proxy server. It's a bare metal server, and that is facilitating the connection between this private network of uh, network, and then this private network is connecting to this virtual network to the software defined network. Fine. So now we go back and try to connect to the proxy, and in this proxy already Apache is running. You can see it is running on somewhere. This port 80 is running, so it's listening on that. Okay. Apart from that, this server, I just want to tell you what are the sites which are configured. We go to so we go there and we can see that yeah, these are the sites which is already there. I think we should delete this site. In my previous run, this site was created, so I'm going to remove this site. Okay. Okay, just to be sure that it is not the current play. No, it is not the current play. It is still in this Django server configuration role going on. So we just delete this file. Yes. Okay. So once again, today the existing configuration is there for OpenStack, and that's all. There is a default configuration. We can also show you there is nothing here. Okay, how, let's say this is. So you can see it's a nothing is there, no sites as such. Okay. I think we'll also remove this one. Okay, I think this is the one which just got created. Let's go back, switch there. Here, you see, I told you when it goes to the reverse proxy, it will be processed very fast. So we were lucky, we just deleted it and it got recreated. Here it is. So what it did is, here it is. It created the reverse proxy configuration file. Okay. This is the line where it has created this task, and then finally it has gone to the server and restarted it. It has created these entries inside the host file. Okay, and finally it has added a lot of firewall rules so that this reverse proxy can be done. So what was done in the reverse proxy, I will just explain you. Yeah, all it says is that the rule says that if any request is coming with a with this name, okay, you should the HTTP request should be redirected to this VM, this name. So therefore, in our host entry, host file, these two entries should be there. Let's do the host file. Do and yeah, it is there. These two lines are entered. Okay, so if this is the case, then our reverse proxy is on, and from from the browser, which was earlier showing service not available, if I browse, it should give me the application's web page. So it is taking little time because of the, as I told you, the Nova computer was on a bad server. Let it come. I'm sure it is coming. That is why it is taking time. Otherwise, it would have given you service unavailable once again. Uh, Let me explain you a little bit about the roles once again. So instead of writing everything in one page, uh, Ansible encourages you to create roles. Roles are a folder structure. For example, when I'm going to create reverse proxy, I have created a folder. Within that, these are the default name of other folder, which means the main program will always has to be there under this folder, and this task is copying. If we go to reverse proxy, fine, let's open this one. Okay, meanwhile, while this page is opening, we see that our applications page has opened for the first time, which means successfully the application has been deployed. So we come back here because now this has opened. Yeah, so reverse proxy deployment needed certain files to be copied. See, this file needed to be copied. Okay, now all this file without any source file actually, you did not give a detailed path. If you just put them under this directory, the role configure reverse proxy, under this there is a file, and just put those files out here, Ansible will file them automatically from this location. And if you have a template or variables, they can be placed here. So that is how the template helps Ansible to minimize work, and also this configure reverse proxy role can be used in multiple places. So it gives you reusability. So now we go back here in the page, and essentially what we started as a play. It took time. Our play was long. That is why I have used this time to explain several other aspects of the Ansible playbook writing, as well as we have explained some sort of the Django-based application model, MDC model. We have also explained how infrastructure can be run as code by uh, by following certain principles of software development. for example, software uh, source management system integrated with automated deployment, which is continuous integration and continuous development. And that whole stack then gives you the DevOps framework. In this application, whether the database is functioning or not, we can go and check it further by going there. We can just call here. If you recollect, we had a model with OS instance. That model is a database table, and entry to that database table can be done through this page. So this is the page through which entry can be done. However, the default deployment has not created any user here. We need to create a user. We can do so manually by going to the application server. We are on the DCIL server, so we can go to our control server. From there, we can log in. Nope, the login is there. SSH. Was it 68? I think 60 is the application server. Let me try here. Okay, so I am here in the server. I have to go to the application folder. The server is overburdened. So here we put the username, email address, so it has been created successfully. You can go to here, admin and the password, log in here. These steps we are doing manually because we haven't thought about creating a user automatically here. Our goal was to just deploy the application. This is the additional stuff here. After logging in, we reach here. We reach here. The OS name is we can give as Ubuntu as the OS name. We know the log file location for Ubuntu is this. For SUSE, the log file location is this. Save this record. This is added. go to our main page and add couple of servers so that it displays here. Then enter some servers here. Come to the screen. So this is server 1. So give some IP. This is the OS we had entered earlier in our screen, and we will save this record. So it has reached to this screen, and now if we go to home page, we'll see that this server is there. So here it is. So likewise, once those records are added, your entire infrastructure should be visible here. From here, there is a facility to select them. Then select the date and time range, enter some keywords, and submit your search. This Django application server that we have created will then in turn connect to all of them using Paramiko, do the log processing, return you the result if these keywords are available or not. That was the purpose of the application. That was a little brief about this. Well, okay, to summarize what we have done, essentially this application was developed using Eclipse. Here it is. This is the application, and then it was pushed to GitHub's. Here is the GitHub, and then we had this is the repository. So developer, let's say, had pushed this code in GitHub, and then the GitHub, then the deployer, the deployment infrastructure professional, he would write down this set of codes for creating the server using the server create role, Nova VM role in OpenStack infrastructure. This is where is the OpenStack infrastructure, and he is not only creating server, he is creating the entire data center infrastructure per se, starting from network topology to the access rules to server and the storage. Okay, this is how he has created the network to server. Okay, and security rules. Once that was done, the next set of rules was used to configure the database server, configure the uh, configure the application server, the Django web server, and finally interface with the reverse proxy, which was pre-existing before all this creation. Push a rule so that from internet this can be reachable. And this entire stuff of after writing all of this, of course, while writing, uh, infrastructure professional need to be engaged here, because how to configure all these components need to be known first, and then only it can be the related module for Ansible can be called. However, this knowledge is now captured uh, in a document. How to configure is very easily readable from this file, and it remains as an organization, as a tacit knowledge to the organization. And finally, you run these roles by typing the command in the Ansible control machine. We have created a control machine. It could be your desktop as well. And this was the command which was executed to run this interplay. which will end to end, starting from well, one more step I had missed is that after writing this code, the infrastructure guy had also pushed this code to GitHub. Here is the infrastructure code. So these are the two codes which will be used in our play once we run this command. These are the two codes which will be executed. Of course, before this, you will run a full command. It is the command is like this. Yeah, you will do a git pull GitHub from GitHub. Uh, Copy this Ansible playbook thing in your local machine, and then you run this command. Then you run this command, and it gets executed. We also described that to avoid this manual step, we could integrate with GitLab, a pipeline uh, facility, or by using a Jenkins type of tool. We could also automate that when developer had pushed the code in GitLab or GitHub, from there itself, this command can be triggered. Okay, thank you everybody for watching. I had to break this video into 3-4 parts because for two reasons. One, for internet connection. Another, I was not sure that how lengthy the one video can be. Uh, Hope that you will go through all the video to see this entire demo. And in the next video, we are going to next demonstration. We are going to certainly enhance our OpenStack in an environment. Okay, we are also working towards improving this infrastructure so that there is not so much of waiting time, pausing this recorder and all are not required. This will be processed very fast. This playbook on this broken infrastructure, I would say, has taken around uh, 1.5 hours to 2 hours time. I lost that time counting, but it would be definitely less than 2 hours time. This entire stack got deployed, including the application. But you have seen when the server is fast, how speedily this is getting processed. So we hope that the time will be reduced to almost 50% when it is going to enhance infrastructure. The last bit of thing which I want to say, that although we are deploying it in our internal OpenStack infrastructure, just by changing couple of lines in your code, here we have a OpenStack auth file. Here in this, we have provided what is the this is the controller and all those authorization URL. By changing them to, let's say, rack space or any other place where uh, it is built over OpenStack, using this, just changing this URL, we should be able to utilize the same API, same module, and the entire infrastructure can be created on any other cloud, giving you a portability between one cloud, private cloud to public, or vice versa, or from one cloud, public cloud to another private cloud. And that's the end of the demonstration. Thanks for your patience and watching.